All right, so we are getting to be in our last throws here. We've got today, tomorrow, and Sunday, and that's it. It's been a one heck of a week, hasn't it? Okay, so I'm probably not going to be on tomorrow, Saturday. I will come up with something to do for your final exam review for Sunday, and I'll try to put it up in the afternoon about this time latest, so that you guys can see something. I'll try for earlier because I know that you guys watch this on YouTube more than you log in, but there's something should be there for you. So we'll definitely try for that. If I need to reset anything for you, or put in anything for late, don't hesitate to ask, because again, I know it's been a rough week for everybody. So I'd rather this not add too much to stress, or at least not add to thoughts of failure or anything. I'm sure everybody put in everything they could up to this point still. So yeah, without further ado, let's do some algebra. Okay, so we're going to go ahead and do that. So I'm going to go ahead and share my screen here. All right. And here we go. And this is 7.5. We did a little bit of the other ones the other day. Just going through here, and I'm just going to warn you to be very careful about parentheses, but there we go. Okay, so let's see here. Let's go ahead and write some of this stuff down. All right, so we have 4x. So let me hit pen here. We've got 4 parentheses x minus 4 is equal to 16. Okay, so this has got to visit both of these, right? The same rules apply with numbers. All right, if I had 4 times 6 minus 4, right, we could say that that's either going to be 4 times 6 minus 4 would be 2, which would be 8. We could also say, right, that that's 24 minus 4 times 4 is 16. 24 minus 16 is also 8. Okay, so this is going to work exactly like numbers, but I can't multiply those two together here. Okay, I can't add those two together. They're different kind of terms. This is the best I can get. So we're going to go ahead and multiply that. It's going to be 4x minus 16, right? 4 times 4 is 16, and that is equal to 16. And then just like yesterday, what we're going to do is everything that's over on the left-hand side, we're going to shove this over to the right-hand side. Everything without an x in it is going to come to the other side. So let's just go ahead and add 16 to both sides here. Didn't touch this yet. 16 and 16, that'll make 32. Okay. Now 4 and the x, right, that's attached by a times. So what we're going to do here is we're going to undo the times. So we're going to divide by 4. Okay, or multiply by a fourth. It really works the same way. Okay, so if you have 100 over 4, I'm going to ask you, is that the same as 100 times a fourth? Right? They are the same thing, right? They're both 25. So it doesn't matter how you write this, really. That cancels, and we have x is equal to 32 divided by 4, and I believe that's going to give us 8. Coincidence, by the way, I did not mean to do that. So let's see if we can't find a couple other ones. Yeah, we can just look at that. That's fine. Okay, so here, right, we have 5, 2n plus 4, and that is equal to 59. Right. So again, this 5 has to visit both of those. Okay, don't forget signs. In this case, you don't have signs, but don't forget to have it visit both. So 5 times 2, that's going to be 10n. Okay, you don't have to do it more than once. All right, if we add 6 times 7, you guys all know that that's 42. If I rewrote my 6 as, let's go with 3 times 2 times 7, right? 6 is 3 times 2. We wouldn't distribute the 3 over, right? We would say 3 times 14 is equal to 42. Okay, so again, just the way numbers work. And 5 times 4, that's going to give us a 20, is equal to 59. Now this one, They weren't very nice with the numbers. Nothing's going to turn out to be too perfect. We get 10n, right? We subtract 20. We have 59 minus 20, and that gives us 39. And then we're going to go ahead and divide both sides or multiply both sides by 1/10. Okay, to cancel that out, we have n, right, is equal to 39 tenths, all right? So what are they? Oh, we have to write it as an integer or a proper fraction. Oh dear. Okay, so this is 39 tenths, right? That's 30 plus 9. We could say 39 is 30 plus 9 over tens. Okay, and you're allowed to break fractions up like this. You can break up the top. Okay, if I've got 4 quarters, I know I have $1. It's okay if I put 3 quarters in one pocket and 1 quarter in another pocket, I still have $1. Which you may not do, right? If I've got 4 quarters, I can't break this up to say something like, 3 over 1, right? Or actually, let's go with, I can't break it up to say 4 over 1 plus 4 over 3. All right, I can't turn my 4 quarters into into $4. All right, that would be very nice for all of us, but that ain't happening. So you can't break up the denominator in anything when you're adding. Okay, you have to just leave it. I can't even break it up into this, right? I can't even do 3 over 1 plus 1 over 4, right? It still doesn't work, right? Because I've got $1. How do I turn it into $3, right? I've got 4 quarters. Now I've got $3 and 1 quarter. Laundry's going to get easier. No, don't work. So 30 over 10, right? And I would recommend go to a multiple of whatever's down here, okay? And that's 3, right? Because 30 over 10, that's going to be 3. And then 9/10. And that's going to give us our n. All right? And that's how you convert. We'll definitely do another one because they definitely wanted an integer, proper fraction, or a mixed number. Okay. I got news for you. Outside of classes like this and outside of elementary school, very few people care about mixed numbers. Okay. Let's see. Let's not go that one. All right, that one. Yeah, let's go ahead and do this one. This one looks fun. So here we have 8y minus 8, and that is equal to 37 minus 7y. So really what this is saying is I've got €8 and I've got an IOU for $8. You figure out what that is. And the other side, I'm saying that's equivalent to 37 euros minus $7. Again, you figure out what the bank is going to do for that. Okay. And you can't. You got to get everything in terms of 1. So what we're going to do is we're going to collect all the y's over here. So we're going to go ahead and add 7y. Right? Add 7y to both sides. It's going to cancel that. So we end up with 15y, so 8 plus 7. And we'll do this in 2 spots. That's fine. All right. And then we'll go ahead and we'll add 8 to both sides because, right, we want all the dollars on each side, or I don't remember what I called which was which, but we want all of that on one side. So we end up with 15y is equal to, I think this is 45. And unfortunately, I mean, this is nice. You don't have to do more work, but we just end up with a y is equal to 3. Right, because we divide by 15, 45 divided by 15, that's 3. So we end up with y is equal to 3 here. Beautiful. That's gonna be too easy. Oh, this is more complicated. It's got 2. All right, we've got 2 minus 6x minus 22, and that is equal to 7x minus 2. All right, this negative sign here, that's got to come along. We really have 2 plus negative 1 times 6x minus 22, all right, is equal to 7x minus 2. So this negative, this is the tricky part of this problem, because really we got 1 and a negative there, okay, because subtracting is the same thing as adding a negative, right? If you have $20 and you spend 5, Well, you have the same amount of money that if you have $20 and you spend 5 on credit, right? You just have to pay it later. So we're just going to say 20 minus 5. So so there we go. So we have to distribute this. So we still have, right, -1 times 6. That's negative 6x. And we have negative times a negative here. We get a positive. Okay, and that is equal to 7x minus 14 there. Okay, same plan. We are going to get all of the variables on one side and everything else on the other side. Since if I put the variable on the right-hand side, we're going to get a positive number. I'm more interested in doing that, just because I think there's less of a chance that I'm going to make a mistake here. So we have 2. What's the sign in front of the 22? Plus 22. All of this cancels out. So this minus sign came with this 6. This 6x and this 6x canceled out. Okay. So again, the biggest mistake people make is 2 minus, and then minus 22, of course. Like, no, the minus goes to the 6. 22 is a positive number. Just write that down. Right? And now we're going to have 7x plus 6x. That's 13x, and then minus 14. Okay. And now what we're going to do, can I say that 2 plus 22 is 24? Everybody okay with that? And now what we're going to do here is we're going to add 14 to both sides. And I end up with 38 is equal to 13x. Okay. So we have to divide, right? We have to say, well, let's get rid of the 13 here. So we're going to have x is equal to, right? This is what we're saying is, well, 3 plus 2 is equal to 5, then 2 plus 3 is also. Okay. Or I should say it this way. If 2 plus 3 is equal to 5, then we can also say that 5 is equal to 2 plus 3. That's all I'm doing here. Okay, and that's equal to 38/13. But again, looking at their instructions here, they want, sorry about my heater, we have integer, proper fraction, or a mixed number. So we got to convert. My nephew will do it this way. I'll write out the multiples of 13 until he gets this one. Okay, it's okay to guess. But with a number like 13, maybe your guessing isn't going to be quite so good. So this is just another way to do it. So we have x is equal to, let's divide this up. This is 26 plus what, right? Is 12. This is all over 13. So we're going to say that x is equal to 26/13, better known as 2, plus 12/13. So our answer here that they're going to want in the book are x is equal to 2 and 12/13. What we have here. 2 and 12, and you have, 2 and 12. What we're going to do is use this button right here. Oh, we're not going to use that button. Not the way I thought. 2 and 12/13. Right. I kind of want to know. Hold on for a second. I want to know how picky about their instructions are there. No, they're not going to let me go back. All right. I'll find out another day. Let's do the last one. Okay. Fortunately, they don't make us do a lot of this in this book. We're just going to have d is equal to h. Now, there's a times implicit here, okay? And I didn't like this problem so much because I didn't know if HQ is 1 variable or 2, but it's 2 variables. It's h times q, okay? We're solving for q, right? So what we're going to do here, right? These are attached by times, so we're going to divide both sides. It's going to cancel, okay? So we have q is equal to d over h. Okay. And let's say q is equal to, let's put a fraction in here, d, they don't want that d over h. Okay. Math is capital dependent, okay? Little h is not the same as big H. Okay, if you do that, you're going to make everybody confused about what you're doing. So don't do that. All right. How do you guys feel about 7.5? Is that good? I'm going to go on to 7.6 and 7.7 here. If you are still having trouble with this, I invite you to say, help me, shoot me an email. Help, I don't get this. Could you do a more focused example somewhere? But hopefully these are not going to be too bad for you. So let's go ahead, knock this out. Yeah, go ahead, leave the page. Let's go back to this one. Oh, let's go back to homework. We did 7.5. Let's have a look at 7.6, right? These do say late, but they're due the last day of the semester. So it's not even correct, because if you turn them in late, you're not getting credit, period, because the semester ended. All right. So let's start off with easy. Okay. So let's see here. Oh, these are rough. Okay. So what we're going to do is we're going to say we're going to translate the following into an algebraic equation. We're going to let W represent the width and H represent the height. I'm guessing we're having a, okay, so we have W, let's go ahead and just write that down, equals the width, and H is the height. And what we have to do is we have to say the height of a tank is 2.6 times width. All right. So there's a couple of different options that we could look at here, right? We could say the height equals 2.6 W's. Okay, or we can say the W is equal to 2.6 H, right? There's a possibility, right? Maybe not. So what are they talking about? They're saying the height H is equal is the 2.5 times the width. So I'm going to go with this option right here. All right. Now you might see these and say, oh, this one was so easy. But yeah, for some people, and I include myself into this population, coming up and unraveling this stuff makes it it is not always the easiest thing. So if it's helpful for you to say something like, well, if the height is 2 times the width, if my width is equal to 2, then my height should be what? And what I'm going to do is I'm going to take 2.6 times 2. That's exactly what this is saying. Okay, that is exactly what this is saying. So if it helps you to put a number in, let's see, 26 times 2 is going to be, what, 50, 52? Yeah, 66 would be 12. Okay, it's 52, 55.2 rather. Okay, but if it makes sense to you to put a number in there and kind of like go through the operation with a number, then that's okay. All right, that is okay. So we're saying H is equal to 2.6 W's. So there we go. All right, they're not the easiest problem. Oh, what do you mean check my answer? What are we doing? Click to select your answer, then click. Oh, check. Okay, they just got mad at me for not following protocol. Whatever. All right. So translate the following into an algebraic equation. Okay, this is the next problem up, so it should be a little bit harder. We're going to let little h represent the height, d represents the density, and little d represents the diameter. Okay, so what are we doing here? We're saying that W is the weight. W is equal to the weight. All right. We want little h to be the height. Little d to be the diameter. And big D to be the density. What are my density? Okay. There we go. Weird. Yeah. In other books, they use radius, so there's usually an R there, and density in chemistry books looks like this. It's a rho, which is the Greek R, but looks a lot like a P. All right. So that's what we have. All right, and let's see here. The weight of the metal cylinder is approximately 0.785 times the height of the cylinder times the density times the square of the diameter. Good Lord, there's a lot to untangle here, isn't there? Okay, so we're saying the weight is. So let's start off with that. All right, the weight is. Let's go to the next part of the sentence here. Weight is equal 0.785 times. Okay, it looks like all of this is times, right? Times the density times the blah, 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 the diameter. Okay, so there's a lot of time. Everything is times in here. Nobody's saying plus or increased or decreased by. It's just all times. Okay, so 0.785 times the height of the cylinder. Okay, so times 0.785 times the height, which is the little h. Okay, times the density. See, I just want to write rho. I don't want to write this. It takes force of will. All right, and times the square of the diameter of the cylinder. So what we have to do is we have to put a d squared in here, right? Because d would be the diameter, and d squared would be the square of diameter, right? So times d squared. All right, that's what they want us to show for this one. Okay, so W equals 0.785 H capital D little d squared. So 7.875 times H times B times, okay, I think it's this one here. So no pluses, you can't fool us. Okay, no pluses here, you can't fool us. We know it's not a plus. 2D, oh geez, it's got to be d squared, got to be d squared. And then, yeah, here they said 2D. All right, so there we go. All right, let's try to pull this up here. Trigger answer, great. So like I said, again, if you are feeling this and it seems like it's taken me a lot longer, it's taking you a lot longer to do these, I've had a little bit of practice, but I definitely feel your pain for, wow, this is, yeah, this is rough. Okay, so let's see here. We have a 110-inch diameter pipe cut into 2 pieces. Okay. All right. And we know that one piece is 4 times the length of the other. Okay. So we got to name things, right? We got to say that we have 110 inch for my length. We don't really need a length over here. We could call one L2 or an L3, or we could say length of short plus length of long pipe. Okay, you can see PS and PL or something. You can say A and B, right? You just say 110 is equal to A plus B. A equals short pipe. B is equal to long pipe. Okay, so as long as you organize it somehow, it's fine. There's no right answer for which one of these you should choose. Okay, so as such, I'm going to go ahead and choose A and B. And then we have to go off and say something like this. One piece is 4 times the length of the other piece. All right. All right, so one piece is 4 times the length of the little piece. So if this is the little piece, let's just say we cut this pipe into, we said one side is 5 and the other side is going to be the rest of it. Okay. The other pipe would have to be, right, if this is a short pipe, this would be 4 times 5 equals equal to 20. Okay. So the long pipe is going to be 4 times the small pipe. Okay. And now what they're trying to do is they want us to use the whole pipe up. Okay, there's an implicit thing here is figure out how long each of these are and that their length is going to equal this. Okay, and here they gave us something to substitute because we said B was equal to 4A. So I know that 110 is equal to A plus B, but B is 4A. Okay, now we can go ahead and add this. We have 110 is equal to 5A. We're trying to solve for A here, right? And it's connected to 5 by the times. So what we're going to do is we're going to divide both sides by 5. So we're going to say, okay, well, then A, right, is equal to 110 divided by 5. What is that going to give us? That's going to give us 22. All right. And 4 times that's going to be 4 times 22, right? That's going to be 88. All right. That's going to give us 88 there. All right. So B is equal to 88. And we can come back and say, well, is the length of the long pipe 4 times the length of the short pipe? Like, yeah, it might seem pretty trivial at this point, but yeah, it is. We're good. And if I add these together, do I indeed get 110? And I sure do. Okay. So it can satisfy both conditions. We're good. We're done. All right. So the short pipe is 22 inches long. Oh, yeah, if we want to leave, we know the long pipe is 88. We're good. All right. Let's see here. Excuse me for that. All right. So here we have 192 concrete blocks. We're going to make a retaining wall. Bottom 3 rows will all have the same number of blocks. Okay. The next 6 rows, I guess we're having 3 plus 6. I guess we're going to have 9 rows here. Okay. So the next 6 rows will each have 2 blocks fewer than the row below it. How many blocks are in each row? Okay. So let's figure this out. Okay. What it's saying? It's saying the first 3 rows. All right. And here's a technique you can use. There's a couple of different techniques we can use for problem solving. One of them, if you can just solve the problem, that's okay. But for harder problems, you might want to solve a similar but easier problem. You could also solve a scaled down version. Okay. Other techniques we could also use is draw a picture. Right? And we're kind of using 1 or 2 of these. Okay. We're doing an example that's probably a scaled down version. And we're also drawing a picture to kind of trace our way through this problem. Okay, so however many blocks are going to be here, and for now, if you want to put it and give it a number, that's fine. If you want to say there's 10 blocks in these rows, that's fine. We could also say, row 1, 2, and 3, and call it R. We could also say B for blocks. Okay, and it says the next 6 rows up, this next one's up, we're going to have 2 blocks fewer. Okay, I don't think we're going to get there. So this would be 8. Could we say this is B minus, pardon me, B minus 2 here? Right. And that's one of those things, when I teach regular algebra class, we have a hard problem. We start off with a numerical model and just say, well, what if I plug some numbers in here and see if we can't make a pattern? That's all we're doing here. We're just plugging this in and we'll see if we can't make a pattern. So the next one down, it has 2 fewer, so we have 6. This is going to be B minus 4. Next one down, right, is going to be 4. And this is going to be B minus 6. Are you sensing a pattern yet? Minus 2, minus 4, minus 6. And I need 6 of these things. Okay, so for my rows, right, we could have row 1, row 2, and row 3. These would all be blocks. These all have the same number. But row 4, right, that has b minus 2. And row 5 has 2 fewer, so it's going to be b minus 4, right? So if these were 10, this was 8, or this was 6 rather. Okay, row 6, that was b minus 2 more, so b minus 6. Okay, and then row 7, right, this is b minus 8. So how many rows we have that are subtracted? We have 1, 2, 3, 4. We need 2 more, right? We have row 8, which is b minus 10. Right? 2, 4, 6, 8, 10. Then we have row 9 of b minus 12. Okay, that's what I think they've gone through and done this, right? Bottom 3 have the same number. The next 6 rows, next 6 of them will have each have 2 blocks fewer than the one before it. Okay, so I think we're okay with how we set this up. I think that works. Okay, let's count out how many B's we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 B's. Let's count up how many IOUs we have. We have 2, 4, 6, 8, 10, 12. So let's see here. We've got a 10, 20, 30, 42. Right? So you see that where it said group to the 2 and the 8 and said that makes 10. So I'll have $10 there. The 4 and the 6 I can group up. That's going to be another $10. So I'm negative 10, negative 20. 10 doesn't need to group with anybody. That's negative 30. And then another 12, right? 30 minus 12, or negative 30 minus 12 would be 42. And how many blocks do we have to start with here? How many did it say we have to use to set this thing up? It said we need 192 blocks. And then what we're going to do is we're just going to solve this. Okay, so we're going to add 42, and we're going to end up with 4, 3, right? And then we have 234, it looks like. Okay, so that's going to be 42 plus this thing is going to give us, yeah, I think we're all right. And then we also have 9b, right? We have 9b. 234. We have 9b. And how many, these are equal. Okay. So next thing, all we're going to do is divide both sides by 9 and hope this came out as a textbook. Okay, so let's see, that's 5. Add up the things, all the digits add up to 9. So let's go ahead and say, what if we have 3 into 234 rather? That's going to be an 8. 21, 21 is 87. Okay, so this is 3 times 87 divided by 3 times 3. It's a fancy way to write 9. Let's go to cancel. 3 can also go into 87 now, can't it? How do you know that? Because 87, if I add the 8 and 7, I get 15, which is divisible by 3. So it's divisible by 3. That only works for 3s. Don't do that with 7s, okay? Doesn't work. So 3 goes into 8 2 times, right? 3 times 2, that's going to give me 6. 8 minus 6 is going to give me 20. Bring the 7 down. We have 3 goes into 27. I believe 9 times. All right. So this number here, this was, we have 237. And that is equal to, what do we have? We have 87 bricks times, and how many bricks were there in total? Right? It's funny. So we have to go up here to our, oh no, we don't. Go to our problem. That's what we have to do. And we have another 192 bricks. Right, just divide. And I believe this is also a whole number here. Divided by I go? I think I lost something along the way here. Yeah, I had like a long blink. Because that ain't right. What did I not do? We have B is going to be the number of bricks. All right. 1, 2, 3. Let's be less. Oh, it's not 87. Lord, it's 9, right? What did I do? What did I just use a calculator? I don't know. I think I closed my eyes and woke up to some weird thing going on here. So 9b was equal to 234. What the heck was I thinking here? B equals. I promise you, this is ginger ale. This is not anything else. Right? 234. 26. That looks like a good number for how many bricks are in a wall. All right. So yeah, let's go on from that. Okay. I know it looks like beer, but it really isn't. It's just ginger ale. Let me go back for a second. What did we say? What did we say? It was 26 bricks here. Make sure I'm not lying to you. Oh, yeah, leave the question. We don't need to know. All right. I have asked this question before. This is a good one. Okay, so we have a photographer has enough liquid toner for 60 4-inch by 7-inch prints. And it asks, how many 10 by 15-inch prints will this amount cover? All right. And don't forget, a print is equal to the length times the width. Okay. So what we're going to do is we're going to figure out the total area that we have for prints here and then divide it by this amount of area over here. Okay, so here's the setup, is that we have enough ink for 60 4-inch by 7-inch things. We have 60 4-inch by 7-inch. So what's that mean? That we have 60 times 28, right? 4 times 7 is 28 square inch. Right, we have enough for that, and that's going to give us 60 times 28 is equal to, so we have enough toner for 680 square inches. And now what we have to do is we say, well, we want to know how many, what was this, 10 by 15 inch things? And there's nothing magic about this, okay? You could break up this 10 times 15 as an area any way you'd like. So 10 times 15, right? We're saying, okay, that's 150, this is 150 square inches. One of those things where I really should have known that. Okay, so how many 150 square inch thing can I make if I've got, so 150 times n, right? That is equal to 680 square inch amount. So let's go ahead and divide both sides by that. That's our square inch. That's our square inch. That cancels, okay? And we get 1680. If you're clever, you've canceled the zeros already. About, we have 11.2. So that's the numerical answer, but we have to put this in the context of the problem, right? You say, great, I've got 11 and 1/5, I've got enough to do 11 and 1/5 of a print. I guarantee you the customer you give the 1/5 to a print to is not going to be a happy customer. Right? So we could say we could make 11 prints. You got to round down. Even if this was 11.9, right? You're still not going to get, well, it's almost the whole thing. Like I know people that have become violent over not getting a whole thing of French fries. So people have killed for less. All right, we're gonna go with 11 prints. All right. All right. Okay. So let's go first. All right, getting to the end here, but so I kind of want to look at the next section here. So let's go ahead and skip to that one. We might definitely come back to these on. Well, might definitely. We might, if you guys have interest in doing the harder problems, chapter 7.6, and I need to do a few more of these, please let me know, and I will release smaller videos so that you guys can see what the heck is going on, and have you walk through this stuff with me. But I don't want to make this one more than an hour. I want an hour is long enough. Okay. An hour, you're going to say allow an hour is too long here. Okay, you'd be right. An hour probably is too long. All right, so let me go ahead and skip out of this and come back. But don't be shy about asking me for that for problems for that one. I'd be happy to show you how to do them. All right. So let's go ahead and take a look at homework here. All right. And we are down at the bottom. We are almost there. All right. Let's have a couple of looks here. Start with question 3 this time. Oh, scientific notation. Hey, we did a little bit of this yesterday. We have 0 point. What do we have here? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 3. Okay, we have to go with scientific notation. So how many places are we going to move the decimal place? We're going to go with 1, 2, 3, 4, 5. We want to make it a decimal, so we're going to go with a negative number. Okay, -5. Because when we are done, we want to unravel this. Right? We want 3, and where are we going to move this decimal place? And I'd like to move it to the left. So that's why it's a negative number. Okay. So it's going to be 1, 2, 3, 4, 5. Put the zeros in the little wells here. And then don't forget the leading 0, because again, I believe we have phlebotomist in our class, so we should use proper notation. We have a nurse too, but we should check. Okay. So let's see. Are they going to let us do it? 3 times 10 to the -5. Are you going to allow me to check? Make sure. Did I not count this right? What are you guys doing? P is a number less than 10 and greater than 1. K is an integer. What the heck is wrong? Oh, let's double check. Count the parentheses, or count the zeros right. So we have 1, 2, 3, 4, 5. I don't see what the problem is here. Use the math palette. That's how you write this, by the way. Yeah, we're just gonna. Okay, are you kidding me? Nope, they aren't kidding. You got to put little spaces in between here. That's their big deal. Okay, so I am just as susceptible as you guys for like, but you didn't write it in the correct way. There's little spaces here. Really? I never saw that. So if that's the mistake you're making and everything else is going well, do not beat yourself up. I am making that mistake too. their editor is really picky. These spaces should not matter, and yet there we are. It probably doesn't like the X either. You know, it probably wanted. I'll show you what it wanted. So this is 1, 2, 3, 4. This is 5 times 10 to the negative fourth. Right, because we have 1, 2, 3, 4. So we're going to put in our 5. Oops, we're going to put in our 5. And when they say they want their math palette, they don't want X. X is going to be wrong. They want that. That's what they want. And see, the space is already there. The space is already there. So they want to be real picky about how we're putting this in here. And what did we say? It was negative 4. 1, 2, 3, 4. So yeah, I think we're okay there. And now we'll check that answer. Oh, you see, now they're happy. All right. So be real careful about that. That's yeah, delightful. Use the multiplication. So if I read the instructions, use the multiplication symbol in the math palette as needed. So if I just read that, I wouldn't have gotten it wrong and look like an idiot. All right. So we have to go right here to the decimal place. Actually, let's go with here. 67, 700. Here's our decimal place at the end here. We're going to go 1, 2, 3, 4. The first number could be a number between 1 and 10. You don't put 67, okay? So it's going to go 1, 2, 3, 4. So we have 6.77 times 10 to the, in this case, when I want to undo this, right, I'm going to want to go to the right. If I have 6.77, I want to move the decimal place this way. So it's to the positive 4, okay? So, all right, so we have 6.7, good Lord, 6.77. It's gonna fool me again. Oh, that. I have to pick up some other way to fool me. To the fourth. All right. And we'll see. All right. So, yeah, the scientific notation is very, very useful in determining different things. When you have to write really big numbers or really small numbers, we talked about money yesterday with that video. I'll make sure that that's up, but that's scientific notation. Okay, and again, if you're running through this, right, because these don't really seem all that. These don't seem to have too many steps. I'm not going to say they aren't tricky because they sure are, but they don't seem to have too many steps. So we're going to go ahead. Yeah, okay, let's do this one just for the sake of doing it. Okay. So here, rewrite the following in scientific notation and then calculate the answer in scientific notation. And if we lived at an earlier age without calculators, you would be better at doing this. Okay, we'd spend more time doing this, but you know, you also wouldn't have, you know, an iPhone and all the other fun toys that we have in the 21st century here. But if you ever have a chance to watch a physicist do math, this is how they do it. It's amazing. I have to keep up with them. So I'm not trying to poke myself and say, oh yeah, I'm so good. Like, no, I struggle too. So let's go through decimal place. 1, 2. So this is 4 times 10 to the 2. Okay. And this guy here, this is 1, 2, 3. So this is 2 times 10 to the 3. We want to multiply them together. Now, there's an old rule that maybe you learned this in high school, maybe junior high for some of you, but maybe you've forgotten. But if you have, the bases are the same. So if I have an a to the 3 times an a to the 5, that's going to give me an a to the, add the bases, 8. So there's a 10 to the 2 and a 10 to the 3. We're going to add the exponents. 2 plus 3 would be 5. And then 4 times 2 is 8. Okay. You can also double check that in the calculator to double check it with yourself. But we want 8 times 10 to the, I wonder if it lets me do this. Oh, it did. All right. got my first job, when I was looking for my first job, like right out of bachelor's degree, I applied at a lot of different temp places, and one of them, Manpower, I think, gave me a test. They said, "Well, can you use a spreadsheet?" And I was like, "Absolutely." They said, "Let's see," and it gave me a test. And for every button, like if you can say put this in the 8 times 10 to the fifth without using the keyboard, then you got a point. If you had to use the mouse to click on the little palette thing they had, then you got no points. If you had to use the window and use, go up one here and use one of the menus, then you got negative points. And you had to get a positive score before they would hire you. So they had all sorts of things like, how do you make a new page? And how do you bold this? And how do you italic that? They just had all sorts of things. And you had to do it all by keyboard stuff. If you touched the mouse, you were losing points. So I don't think they test like that anymore, but I'm always used to, always aware of it. Okay, it's going to be a very similar thing. Okay, so here we have, all right, this will be the last one we do for it now. But again, if these are tricky, I hated these in high school. I completely get how frustrating this can be, and I hope I did a reasonable job explaining this to you. But we have 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 4, 8. 0.0020. We put on my leading zero. We don't count the leading zeros for scientific notation. Okay, so we have to do, we have 1, 2, 3, 4, 5. We have 4.8 times 10 to the negative fifth divided by 1, 2, 3. So we have 2 times 10 to the negative 3. Okay, and division, right? We subtract them. So we have -5 minus a -3. So that's still going to be, right, -5 plus 3, that's going to be -2. And we have to do, what's 4.8? What's 48 divided by 2? Right? We're going to get 24. Okay, so we have half of it, right? So we have 2.4 times 10 to the -2. Right? So who is this going to be useful for? You say, well, I have a calculator, I have a phone, I'm never going to need this. Like, I got news for you. In your biology labs, they ask you questions like this, and they didn't allow you to bring a calculator to the lab. So they want you to be able to do this kind of quick arithmetic like this. So there are still classes that insist that you are able to do this without a calculator. It's good practice anyway. If you ever wanted to look at, let's go ahead and type that in there. If you ever want practice using math skills without a calculator, I got thrown out of a Walmart one year for using a calculator. I don't know why they thought they were, but security was really upset that I was carrying a calculator around inside the Walmart, so they asked me to leave. But I remember being, poor enough to care, to really have to watch my budget, and I still have to watch it. Okay, it's just that I can approximate a little bit more now, but I still got to make sure. So when COVID leaves and you're walking around in a store, okay, track how much you're spending in your head and see how close you can get. Okay, or if your significant other will allow you to keep track of what you're spending in a restaurant, as people ordering, you can track it and see how close you get to the total when you're all done. Okay, and the more you practice, the better it's going to go. For me, I would have to count my pennies for the grocery store, so I would have to know how much the bill was going to be by the time I got to the end, because I didn't want to overspend. For an added challenge, if you have a toddler, try to figure out that, because that's going to be extra random variables thrown into your cart that you didn't account for. So you got to kind of make a margin for that. Okay. But it's just practice. It really is. Doing a mental arithmetic is just practice. And the poorer you are, the more important this is. Okay, so if you're worried about making laundry or making rent for a month, and you gotta count your pennies to get your groceries done, and you're gonna get better at this. Okay, but even if you don't have to, or you don't have that sum of a margin, you should still practice knowing how much your groceries are going to be by the time you get to the cashier. And you can make a game, see how close you can get. And it's not going to go well the first couple of times. So you get better. Okay. So with that, I'm gonna leave you for the evening, and I will respond to you via email on Saturday and Sunday. Don't wait for the last minute for your finals. Start it early, because you never know if power goes out. We live in New Mexico after all, which means power sometimes goes out. Sometimes you lose internet access. And I'll try to put a review up earlier in the day on Sunday so that you'll have something to watch to review on before you do that. But don't be, you're allowed to ask the questions. Okay, if you get stuck somewhere, let me know. That like, hey, I'm stuck here. Could you do a video to help? I'll do one. All right. So good luck. Do your homework, and I will see you on Sunday. All right, we're going to stop recording.